Hey everybody, we're here in the Arduino IDE. I'm Brian Jenkins, creator of Arduino Academy, and I hope everybody is doing great. Now, this time we're going to talk about an often underappreciated thing, logic and arithmetic. Logic and arithmetic are one of the foundations of any programming language. Now, I know some of you may be tempted to skip this lesson because you think you already know how to add and multiply. But arithmetic and logic in programming is so much more than that. And since most of your useful programs will include arithmetic and/or logic, it's important to understand how it works in Arduino. Regardless of your age or grade level, if you're still in school, I totally urge you not to skip this lesson. While many things about arithmetic and logic may seem obvious and boring, there are some caveats and gotchas. Even if you've been programming for a while, this lesson can serve as a good review of the basics. Now, with that said, I'm not going to teach you math. Now, I know that sounds kind of weird and contradictory after I just said we're going to learn about arithmetic, so let me explain. What I mean by that is I'm not going to teach you how to add, subtract, multiply, or divide. You guys should already know that. Rather, we're going to learn about things like order of operations, modulo division, which if you're new to programming you may be unfamiliar with, operator precedence in Arduino, and more. So let's get started. The symbols for addition and subtraction in Arduino are the same ones you are familiar with. And to multiply, you use an asterisk. For example, the statement you see here multiplies b by 27 and then assigns that number to variable c. And we'll talk more about the assignment operator in a minute. To divide in Arduino, you use a /. For example, the statement here divides b by 27 and then assigns that number to variable c. And here comes the first caveat of arithmetic in Arduino that will make watching this video worthwhile. Integer division yields an integer quotient, or an integer answer. Understanding this will save you hours of frustration trying to track down hard-to-find logical bugs. In other words, any fraction or remainder resulting from integer division is discarded. This process is called truncation. And let's do a little problem to illustrate this. Now, I want to use a serial monitor, so I'm going to start by doing a serial.begin so we can see what kind of answers we're getting from the arithmetic we're going to do. And that's all we need to do in setup for this. So let's divide 5 by 4 and assign it to a variable, integer variable c. And then let's take a look at the answer. Insert a small delay in there so we have time to actually read it. And let's go ahead and see what happens. So here we go. A calculator will give you an answer of 1.25 or 1 1/4. But the Arduino language is giving us an answer of 1, dropping the 0.25. And similarly, if we were to divide 7 by 4, we'll get an answer of 1 rather than 1.75. Now, sometimes this may be acceptable depending on what your program's supposed to do. For example, depending on my project, I may not care about the remainder or fractional part of my answer and only want the whole numbers. Most of the time, though, it's probably not acceptable. Now, the float variable type will get you around this little gotcha. So if I want to divide 5 by 4 and get a true answer, I would write something like this. And now we see with floating point division, we're getting a real accurate answer without truncation. Now, some of you may be wondering why I added the extra 0.0 on the end of 5 and 4. Why didn't I just type 4 and 5 instead of 4.0 and 5.0? If I want an exact answer in Arduino, I need to add those zeros on the end. If I don't, here's what happens. If I don't add those zeros, here's what happens. I get a weird result that looks like integer division got together with floating point division and had some kind of freakish looking baby. What a crime against nature. Anyway, one last point about this. When you mix integers with floating point numbers, the answers come out the same as floating point arithmetic. The Arduino isn't really capable of dividing a floating point type by an integer type, so the compiler automatically converts both operands to a single type. In this case, the integer converts to floating point before the division takes place. For example, doing something like this still gives us an answer of 1.25 rather than truncating and giving you an answer of 1 or giving you some weird 1.00 answer. The nice compiler converts the integer 4 to a float of 4.0 without bugging you. Now, let's talk about the order of operations in Arduino.